So again, in rectangular sections, the variables would be the width. B usually is going to be given to you. Total depth is going to be H. Also, this has to be given to you. AS, usually it's either that you estimated, you come up with an estimate, good estimate, and you learn how to do this, or it's going to be also given to you. Also, material properties. Let's say if I didn't give you the concrete strength, what would you do? Then, I mean, you just look at some of these examples, right? Usually your backup information is going to be this, all of these slides. So you just go back and pick some reasonable value. You don't go 6,000 or 7,000 concrete, but you go maybe 4,000, maybe 4,500, 3,000, some value there. You pick something there. If the steel is not specified to you, so you use grade 60, which 60 KSI, yield strength. So if I didn't mention it, don't say, oh, I have misinformation. No, it is not missing, but you need to come up with your estimate. Also, the location or relationship between D and H. As you know, in previous examples, we have used this to be 2.5 inches. So if I didn't give it to you, just take it 2.5 inch. Okay. So the question is, I understand that this is good for a beam, right? When you have, this is like a beam, rectangular section. And if I look here in this picture, I'm gonna say, I don't really have a rectangular beam. Usually the beam is gonna come with a flange on the top. It's gonna come with some concrete slab. But in reality, it is really, I mean, it is really odd if you see here a rectangular section like this without concrete slab. Also, we need to think about this. Also, if you like to design the slab itself, so let me go back here. Let's say that I'd like to design this slab. What should I do? I'd like to put some reinforcing. I'm not now designing this beam. I'd like to design the slab. So I need to cut a section through the slab, right? So my section is going to be in this direction. You say here's going to be my section. If I may zoom in. And the reinforcement is going to be in the top, bottom of the slab. It's going to be right here. It's going to be running this way. Now the span of this slab is going to be from here, from this point, let's say the center of the beam to the center of this beam. It's going to be the span. So I'm going to call this to be slab span. The slab span is going to be the same as the distance center to center from this beam to that beam. And this is a term that we usually say. We say that the slab is spanning between these two beams. Therefore, these two beams, they act as supports to this slab. Now, when it comes to this slab, if you like to design it, you need to take a section. And the question is, how much is the width of this section? Which is the width, which means from here to there. So I'm going to take you here and say width meaning like B. And the depth, total depth H, is going to be the same as the slab thickness. It's going to be the same as this thickness, right? So if this section here is taken through this beam here, right? It means I'm looking for this reinforcing. It's going to be running in the slab itself. I'd like to design this reinforcing. So I don't want you here to be confused between the beam reinforcing and the slab reinforcing. If you have two of these beams, it's going to be here's one beam. Let's say here's the other beam. I'm going to say it's going to be happening somewhere here. Just disregard this. And now you need to have this reinforcing. This reinforcing around at the bottom is going to be the same as this reinforcing that I've just drawn here. And on the side, this reinforcing is going to be right at the bottom here, right? It's going to be right here, if you like. And it's going to be kind of repeated. So in this case, I cannot call the reinforcing of the slab, let's say 3 number 8, because usually when I say here 3 number 8 or whatever, right, I need to define the width. But now this slab is just simply extended. So in this case, instead of saying 3 number 8 or put the number of rebars, I'm going to put the rebar and the spacing of the rebar itself. So I'm going to be taking this aside. I'm going to say now I need to, when I call the reinforcing or when I specify them, or if I'd like to consider in my analysis, I'm going to say I'm gonna say I need now the spacing of this reinforcing bars, right? And this is gonna be the reinforcing bar, the way that I'm gonna be calling out the reinforcing. So in a beam, you call out the reinforcing as total number of rebars. In the slab, you call it by rebar and the spacing. For example, I can come here and say slab reinforcing is gonna be number 5, which means the rebar is gonna be number 5, right? Number 5 at, let's say I'm gonna throw some number there. I'm gonna say 16" on center. So what does it mean by that? It means that this rebar is gonna be number 5 for the size, and the spacing from a rebar to a rebar is gonna be 16 inches. Is gonna be on center, which is the spacing from the center to the center of the slab. If this makes sense to you guys. But the question is, how much width should I consider here for the slab, right? This is gonna be our section. Should I consider the entire width from here to there, knowing that this is gonna be kind of repeated? I'm gonna have here number 5 and 16 throughout the entire slab. I'm gonna say, well, in this case, let me just take 12" width. So I'm gonna take a strip, and the width of this strip is gonna be 12 inches. And in your analysis, you assume here that you're gonna be repeating this strip. So we're gonna have one strip here, you have another one here, right? Another one here, and you just keep on repeating it, and so on. So in your analysis, the width B is gonna be equal to 12 inches, right? So this is gonna be the strip, right? The strip width. So what does it mean by strip width? In your analysis, it's gonna be what? This is gonna be your B. B equals 12 inches in my analysis. Now I'm gonna repeat on putting all of these reinforcing bars. And the question is now, how much is this AS that I used to use in my analysis? If you remember here, AS, if you look here, AS was equal to total number of bars multiplied by the cross-section area of one rebar. So I'm gonna say, where do you have this cross-section area of one rebar? I'm gonna take you here to this slide set. You go, let's say number 5 is gonna be 0.31 square inches. This is gonna be for one rebar. But once you put here the spacing, the question is how much AS you have per each 12 inches. So we need to learn the trick. How can we do this, right? We have this new slide set. This is gonna be number 5. It's about the one-way slab reinforcing design. One-way means that the load is only moving in this direction, meaning that I don't have any beams connected between here A and C. You see here, do we have any beams between A and C or B and D? You see, no. Therefore, all the load, if you put here any point load, is going to be going to this beam AB and to the beam CD. No load is going to be moving in this direction. So the load first is going to be coming from the slab to these two beams and then to the columns. In this case, I call this going to be one-way slab. Now let's look here at the slab design and definition of one-way slab in more detail. Here is one-way slab and also two-way slab. And you'll notice here that the reinforcing is going to be like two meshes, top and bottom, is going to be in both directions, right? You have the reinforcing in both directions. But in my discussion here, I put the reinforcing in only one direction. Someone's going to say, how about the reinforcing here? You're going to say, when we come to the reinforcing this direction, we're going to put the minimum as required by code. You remember in the previous lecture, we were talking about the minimum reinforcing that you put in the concrete beam. Here's going to be something similar to it. You need to put some reinforcing, it's going to be the minimum. Sometimes the minimum is just enough, but we need to do the check. But you cannot ignore the reinforcing in the other direction, not to add any reinforcing. You need to add it to both directions. This is going to be like the main direction, and this is going to be like secondary direction, if you like. Here's the standard slab reinforcing. You're going to see it in both directions. How about the section design? You can say section design is going to be very similar to what we have learned. It's going to be like for rectangular section. Can we ever have like a T section when you're doing slab design? I'm going to say no, because look at this. It is really a rectangular section. The width of it is going to be here 12 inches. And the depth, total depth H, is going to be equal to the slab thickness. And this can be maybe 6 inch, 8 inch, 12 inch, depends on your design. Everything that you have learned in the rectangular section is going to be exactly the same. So this slide is just copied from previous slides. How about this one? The flexure strength. You can see exactly the same. You have the tension, you have the compression, right? And then you're going to set them equal to each other, and based on this, you solve for A. Meaning, in this case, AS and FY is going to be a known term. F prime C and B, and all of this term is going to be also known because the width here, in this case, in a slab is going to be 12 inches. So let me put this right here. I'm going to say for slabs, B equals how much now? 12 inches. So I don't want anyone to come back and ask the question and say, what width should I consider for this slab? Because we know it's going to be usually 12 inches, right? F prime C is going to be either given or you assume it. Most likely maybe 3,000, 4,000 concrete slab. F sub Y not given is going to be 6 KSI. AS is going to be whatever that you'd like to start with or assume and also given to you. We're going to be going through this. The strength, the nominal strength, if you remember this term here, nominal strength, which means MN, this is not the capacity or the strength of the beam or the slab, is going to be based on ASFY D minus A over 2. If you like to know what is that about, I'm going to say D minus A over 2 is going to be the distance from the tension to the compression component. So, okay. Let's look here at one example for slab design, and let's apply all the things that we're trying to learn here. In this example, it says 10-inch thick one-way slab. So now I understand it's going to be one-way slab. Do we have two-way slab? Yes, we have something that's going to be called here two-way slab, but it's not covered in this course. So usually if we say slab, it's going to be one-way slab. Even if we didn't say it's going to be one-way slab, it's going to be one-way slab for the purpose of this course. The span is 14 feet. The span is the same as the distance between the two supports, as if the slab span from this point, right, to this point is how much now? 14 feet. The distance from here to the center of this beam to the center of this beam is going to be, as given here, 14 feet. Concrete strength 3,000 psi. The steel, as I said, is going to be grade 60. F sub Y is going to be equal to 60 KSI. Dead load includes the slab self weight and additional dead load of 7 psi. So what does it mean? Now we need to understand what is this slab designed for. I'm going to have here two components, dead load and life load. Usually dead load is going to be the self weight plus some additional dead load. Self weight means the slab thickness, right? The slab itself, the weight of the slab. And the additional dead load, it says here 7 PSF. We need to understand what is that for. And this 7 PSF is going to be for, let's say, ceiling, tiles, some additional conduits, whatever piping below the slab. This is going to be supported to the slab itself. So it says here, just consider 7 PSF. Addition on the top of the self weight. And you'd call this dead load. Life load is 50 pounds per square foot. So given. Let's see here, check if number 5 at 16-inch on center is sufficient as bottom reinforcing in this slab. Why it says bottom reinforcing? Look at this. This slab here, supposedly it is extended. So this is not like a short cantilever, just extended, but they stop it right here. In our case, our slab ends right here. We don't have this. It's going to be only one span. Our slab of this example is going to be only one span. Right? It's going to be one span. And when the slab is going to deflect, it's going to be coming down this way. Just think about the deformed shape for this slab. Just exaggerating here. Right? It's going to be down. Which means the bottom reinforcing is what we really need in this simply supported span. Why? Because we have positive moment. Tension is going to be in the bottom, compression is going to be in the top. So I need the bottom reinforcing. This is why we say here, check if number 5 at 16-inch on center is sufficient as bottom reinforcing. So why bottom? Because I'm going to have here positive moment. Now I have two components. I have demand, which means how much I want this slab to support, and then I have the capacity, which means the capacity of the slab itself. Now, dead load first. I'm going to start here with dead load. I'm going to say dead load is going to be equal to the slab weight, self weight of the slab, and additional 7 PSF. I want to do it as in PSF. So I want to do the self weight as in PSF. I know that 1 cubic foot of concrete weight how much? Can someone help me?
150.
150, yeah, which is right here. But this slab thickness as a 10-inch, this is not in feet. So I need to convert this into feet. I'm going to say here 10, 12 by 12. Take the slab thickness, right? Divide by 12 to put it in feet, multiply by 150. With that, this weight here is going to be the self weight of the slab as in PSF. Let's say this is going to be here self weight. Then you add 7 PSF to it. It's going to be that simple. So you end up with 132 PSF. This is going to be your dead load. Now, do I need to do any analysis for the live load, or the live load is just given? Let's say live load is just given. Just use it as is. I'm going to say here, just to make it short, I have this W ultimate. It's going to be equal to 1.2 dead plus 1.6 live. Do you guys know where this is coming from? Anyone knows? Did you guys see this before? Do you know the source of it? Yes or no? Okay, so what I want you here to do is just take a note of this slide set number 3, and the slide is going to be number 19. We said that we are going to be using this load combinations, and the load combination includes 1.4 times dead versus 1.2 dead plus 1.6 times live. And we did this exercise on this, right? I assume dead load and live load, and then we try this. We figure out that the 1.2 plus 1.6 is going to be controlling your design. It's going to get you here the higher of the two values, right? This one here, you can do it in moment. So this D can be moment. It can be uniform load. It can be linear load. It can be axial load. Depends. So I'm looking here for this load combination. I say dead load is going to be 132. It's going to be 1.2 times dead plus 1.6 times live. 1.6 times 50, the live load. 1.2 times 132, which is the dead load. You have total of 238 pounds per square foot. This can be your demand load as uniform load. Right? I'd better put it in KSF. Just divide this by 1,000.
Professor, just
Yes.
real quick, where did the 150 come from when solving for the dead load?
This one? This is
Yeah,
unit
I
weight
did
of concrete. Generally speaking, this is a very good question. Thank you for asking. This is going to be unit weight of concrete. And we mentioned before that usually unit weight of concrete, you see this? I want you please to remember this. If you don't know the unit weight of the concrete, you take it as 150 pounds per cubic foot.
Okay, thank
One
you.
of the standard, no problem. One of the standard values that you need to be aware of. Very similar to E of steel. You guys know what is ES for the steel? Anyone knows? What's the standard for all steel, all type of steel? Yeah, you guys see it?
29,000.
29,000. This is like a constant for all materials, right? For the steel material. Do you know the unit weight of steel? Density of steel, let's say. Do you know the density of concrete or unit weight of concrete? Unit weight of concrete is how much?
150.
150. How about for steel as a material? How much is that? Unit weight of steel. Do you guys know?
90.
How much?
Is it 90?
90.
490.
Yeah, 490. The steel is much heavier than concrete, right? As a material. So, all right. So I guess we are good with this dead load. Now we know where it's coming from. And also we're good with the live load, which is just given. And now your load, uniform load, is going to be how much? 238 PSF or 0.238 KSF. If you like to consider here 1 foot strip, right? Just imagine here is 1 foot strip. And here's the support, center line of the support, just like I'm looking from the top, like plan view, right? Center line of support. And the distance from here to there is going to be 14 feet. Now I have taken only 1 foot, right? Which means this number here is true. And W ultimate, I can put it as, it's going to be the same as 0.238, right? Yes, say here, kip per linear foot, KLF. which means kip per foot. Are you guys with me? How did I do this? I've just taken this W ultimate as in kip per square foot, multiplied by 1. Why 1? Because the width of this strip is going to be 1 foot. I'm going to say here, strip width. Equals how much? I'm going to say 12 inches, like a foot. Now I have no problem with this because all what I need to do is just multiply by 1. This is going to be the width I'd like to consider in my answer, right? All right, how about the moment? I guess you guys now should be very good in moment, right? Moment diagram, you guys have done it for simply supported beam. The moment equals W L squared divided by 8. Any questions on this moment value, the maximum moment? You guys are good with this, or do you have any questions for me on this? Yes, no?
For the moment, how do we know which formula to use for like the WL squared over 8? Is it always this way?
This is a simply supported slab, am I correct?
Oh yeah.
Okay. Do you have uniform load or concentrated load on the slab?
Uniform
load.
Uniform load, 70, 7 PSF, self-weight, so this is going to be all uniform. When you have simply supported uniform load, this is going to be the equation you use.
Oh, I see. Thank you.
Right, no problem. How about this? Let me show you this. This is going to be for beams, right? Or slabs. Just speaking for beams, right? Because the slab acts as a beam. I'm going to say, when you have a case like this, like more than one span, right? How can I do here the moment diagram? You see the moment diagram? How can I do the shear diagram for something like this? Continuous beam, 3 equal spans or more. How can I do it? This is not now W squared over 8. So I'm looking at this. This is taken from the Steel Institute, right? From the Steel book, if you like. And look at the moment diagram. How much is this? This W squared divided by what? By 10. W squared divided by 10 for the negative moment. How about the positive moment? It's going to be this number here, 0.025 W squared, right? This one's going to be 0.08 W squared on both sides. So if you have continuous beam, this is going to be the business that you need to do, right? Now you have the shear diagram and the moment diagram, so you can do it based on this. You can just use these values when the spans are kind of equal, which is very common in our business. If you have fourth span, you're going to be just taking this value and throw it here, and the negative moment is going to be also W squared divided by 10. Which means if you add 5 to 6 spans, you're going to end up with negative moment to be the same, right? Which is going to be good for design purpose. And for the positive moment, first span and last span is going to be 0.08 W squared. And all the intermediate spans is going to be 0.025. So I guess by now you understand these factors, why I put them in red, right? With this additional span. Any questions on this?
Hi, Professor.
Yes.
Can that moment diagram be found in the on Canvas? As a PDF?
You have it on Canvas. I posted already there. So whenever you have a chance, just go to it. But the good thing is you have a way of doing it without doing lots of structure analysis. Okay? When you have discontinuity, because this is indeterminate structure. So when you have simply supported, this is going to be your moment, right? W squared divided by 8. It's going to be that simple. Now I'd like to try this. So this is going to be your demand here, right? It's going to be 5.83 kip foot. It's going to be your moment demand. How is that? 0.238, 14 squared, which is a span squared divided by 8. Here's your moment demand. You want this concrete slab to support 5.83 kip foot. Now you'd like to add reinforcing to take this force. So I'm going to try here number 5 at 16. That was recommended to me, so I need to try that. Yeah, say in this case, I'd like to take here 12-inch slab strip. This is good. How much did they have as an AS? Because if you put here 12-inch next to a 12-inch, if you just imagine that you put this here, right? Here's the first 12 inch. Here's the second one. Here's the third one. And then you start to put the reinforcing, and the reinforcing is going to be at 16 inch. It means maybe the first rebar is going to be here. Now, where's the second rebar? Do you think it's going to be within this slab strip? Well, maybe here, right? And then what's happened for the next is going to be here. So there's something weird here because one of the strip will not have any reinforcing. So I don't like that. But what I'd like to do is to look as an average, how much reinforcement do I have per 12 inches? Does it make sense?
How do you know that it's not going to have reinforcement?
Because look at this. This here 12 inches, right? Now we start to think about this. Here's 12 inches, correct? If I put the slab here, if I put this reinforcing in the middle, how much left from here to the edge of the strip? How much?
Half the distance.
Like 6 inches,
So
correct?
6 inches, yeah.
Okay. And the spacing is how much for the reinforcing? 16. This is going to be 6,
Oh.
and this is 12, it's going to be 18. So this is going to be happening right here. How about the next one? You're going to say, well, I have your couple of inches and 12. So this reinforces is going to be out here. So now we ended up with one strip, right? This strip here, if you think about it, this strip doesn't include any rebars, right?
Right.
So this is not good. You're going to say, but this is not the intent of our design. So what we'd like to do, as if you're going to be cutting a section here, and look at the bar spacing, and then look on average how much reinforcing or AS you have per 12 inches, which means per strip, on average, right? How can we do this? I'm going to say, if I have rebar at 16 inch, this rebar happens here, 16 inch, you have another rebar, 16 inch that you have a rebar. If I take the cross-section area of just one rebar divided by the spacing, let me give you a quick example here. I'm going to say, I'm going to be taking AS to be 0.31. What is 0.31? Cross-section area for one number 5, okay? Divide this by the spacing. What's going to be the result of this? I mean, what value are we talking about? This can be inches squared, the cross-section area, per inch. So for each inch of this concrete, I have this much reinforcement. Does it make sense or no? Yes? No?
I'm sorry, Professor, can you repeat that one more time?
This 0.31 is going to be square inch, is going to be the rebar cross-section area, one number 5. So this guy here is what? This is going to be number 5, right? The one that I'm pointing at here is going to be number 5. And also this one is going to be another number 5, which is right here, right? Another number 5. Now, I don't really need to look at this slab strip. It's not critical to me, right? Just give it the reinforcing. Each one of this line, right, is going to be a rebar, which is number 5. And the spacing is going to be 16 inch, 16 inch, 16 inch. So on average, if you take cross-section area of one of this rebar divided by the spacing, right, it's going to be 0.31 square inches, the rebar cross-section area. You divide this by the spacing, you're going to end up with the cross-section area of the steel per 1 inch of the slab width. It's going to be only for 1 inch as an average value, you know. So if you take here 0.31 divided by 16, can someone help me with this? How much is this?
0.02.
Something like that, right?
Yes.
Okay. So what does it mean by this? I'm trying just to understand it, right? I'm going to say it means for each inch of the slab width, which means in this direction here, you're going to have 0.02 square inches of steel. But I'm not really interested in this. I'm interested more in how much do I have per 12 inches. So this going to be here, this is what I have here per inch. I'm going to take this 0.02 times 12. How much is that?
0.23.
What? Square inch per what?
Per
Per foot. correct? Which means for each 12-inch strip of the slab, I have 0.23 square inch. And this will be my AS, and this is what I need to use in my design. Let me repeat this here. Take this 0.31, divide by 16. What is 0.31? 0.31 is going to be AB for number 5. What's 16 inch? The spacing. You're going to say here rebar spacing, right? So let me point at it and say rebar spacing. So what is this 12 inch? I'm going to say this 12 inches now is going to be the width of the strip. Now it makes sense. Now this is exactly the same calculation that I have done here. You just take the 0.31 cross-section area for one rebar, divide by 16, multiply by 12. Exactly what we have here. But here it is more of understanding it physically. Here it is one of this common equation that people would just use. Now, once I have this, I'm going to treat it as a simple rectangular section. I'm going to assume here that the steel is yielding. Here is tension equals AS times Fy. So we're going to say here this is going to be times Fy, which is missing here as a symbol, F sub y, right? So T does not equal to AS, it's just missing. So AS times F sub y, right, is going to be 60. Here we go. I'm going to have here 13.98 kip per foot. Have you ever seen tension as in kip per foot? I'm going to say yes, because this foot here is going to be the width of the strip. I said, okay, I understand. Everything is here is going to be per a foot, strip width. Now let's look here for the depth. Depth is going to be 10 inch. How much is the clear distance? Because I'm thinking here, I'd like here to relate the depth, right? D to H. So this 10 inch is going to be H. So I'm going to say this is going to be H. Where do I have it from? Or where did I get this from? I'm going to say from here. It says here 10 inch thick. So this 10 inch is going to be the total thickness. It's going to be H. How about the depth D? Now someone's going to say, in concrete slabs, it's going to be different from beams. In beams, I'll need to have maybe 2 inches of clear cover. In concrete slab, I'm going to have maybe an inch of clear cover. So when you're doing here slab design, just take D equal to the H, total thickness, subtracting 1 1/4 inch, and this is going to be your depth. So next time when you see a homework or a project, and then you'd like to figure out the depth, just take maybe 1 1/4, maybe max 1.5 inch. Okay.
And the clear coat, the clear coat would go from the bottom to the
Yes.
center of the rods. Okay.
Yes, this is very similar to what we have done before, like in here. But in this case, this clear cover is going to be only 1 inch in slabs. Okay. I said, okay, let me now set the tension equal to the compression, and with that, I'm going to be solving for A. Look at the A value, it's going to be very small, right? As you see here, 0.46 of an inch. How about the phi factor? I'm going to say, yeah, phi factor, if you can find out the C by D, you remember this exercise, C over D is going to be 0.062. 0.062, you're going to be right here, which means tension control and strain in the steel is going to be much more than 0.02. So my assumption is correct. And also phi factor is going to be equal to 0.9. Great. So I guess after this, I can do Mn. The tension times D minus A over 2. Good. How about after this? Apply the phi factor. I'm going to have here 8.93 kip foot. This is going to be the capacity that you guys have learned before and you know how to do it, right? So with that, I need to compare it with the demand. Your demand is equal to 583, now compared to 893. This is good, right? You have enough reinforcing here. This is going to be the bottom line. So you're reinforcing number 5 at 16, it's going to get you a capacity of 893. The amount of moment that you want to support is going to be only 5.83. And the question here, or the question right, it says, and that is only for concrete slab. I guess you're talking about the concrete cover. So I'm gonna say concrete cover for slabs is gonna be 1 inch. So in order for you to figure out D based on H, you subtract 1/4 to 1.5. In beams, it's gonna be about 2 inches, and you subtract maybe about 2.5 inch. Okay. All right, how about the minimum reinforcement? What should I do about the minimum reinforcement? I have 2 ways of doing the minimum reinforcement. Just you guys, if you remember this issue. Let me put the previous slide set. When you have a beam, minimum reinforcement is going to be given by these equations. If you remember the equations for the minimum reinforcement. In concrete slab, you don't do that. I understand it looks like a beam. It's a rectangular section. But in concrete slab, the minimum reinforcement is given by this equation. It says here AS minimum is going to be a ratio of the concrete slab cross-section area. I'm going to say, here's the cross-section area of the slab. How much was the width? Can someone remind me, please? B equals to how much?
10 inch.
12 inches, right? How about the total depth? Say H equals 10 inches. 10 inches. Okay. Slab thickness, strip width. What's the minimum cross-section area? It's going to be 0.018 of this cross-section area. So take 10 times 12 multiplied by 0.0018, you end up with 0.216 inches square per foot. Why per foot? Because this was calculated for the strip of a foot. How much do you provide? I'm going to say, okay, let me go back here and confirm this number. AS equals 0.233 square inch per foot. Yeah, this is what I have provided, more than this value here, which means this is okay. I was able here to provide more reinforcement that needed based on the minimum. So I covered the minimum reinforcement needed for the slab, and my design is okay. Any questions? By now, you guys, you should have an access to the project. I posted already the project. And the project submitted is going to be equivalent to a homework. Here's the project statement. We have general information on this project. 4-story office building. Story height 14 feet. Soil bearing capacity 3,000. We'll be doing some design here, right? We're going to be doing slabs, beams, gravity columns, footings, and basement walls. Concrete strength shows this to you. This is what you need to use. It says here for 2-way slab and also 1-way slab. So let me put this. Just say and 1-way slab. I'm gonna change this in the original document. 4,000 for the beams, 4,000 for the columns, and for the foundation is gonna be only 3,000. All the reinforcing needed is gonna be grade 16. Load criteria. We're gonna have dead load and life load. Your dead load is gonna be self-weight of the structural members. So for example, when you design the slab, it's gonna be only the weight of the slab. When you design the beam, it's gonna be the weight of the slab and the beam. Why? Because the beam supports the slab. And then you have additional dead load of 10 PSF. In our example here, the additional dead load was equal to, anyone recalls? It says here 7 PSF. But on our homework or submittal, it's gonna be 10 PSF. Life load. Just so you guys, the partitions is life load. So whenever you have partitions inside the building, we consider to be life load. The floor life load is 50 PSF. Roof life load is gonna be 20 PSF. So now I need to show you the plan, how it's gonna look like. Here's the plan of the building. Here's the building. It's gonna be 130 feet by 84 feet. I have here some elevator in restrooms in the middle, some walls. You're gonna have here some concrete walls and then columns. The grid line is spacing for the column in the x direction. That's what you call here L sub x, which means the span in the x direction is 26 feet, and the y direction is gonna be 28 feet. Another plan here, it shows the beams and the slabs. So look what happened. This could be like one strip of the slab. I highlighted this in yellow, so you guys know which slab you're gonna be designing. In here, I'm gonna have a strip that goes for how many spans? I'm gonna say now I need to look at the beams. Look at the beams here. See this beam? Starts and stops. And look at this. This is what we call here a girder. So I'm gonna be calling this a girder, right? Which is this guy here. This one here, I call this a beam. So this beam supports directly the slab. And then the girder supports all of these beams. Now let's look here at the slab first. How many spans do I have for this first strip? I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 spans. I'm gonna have here top reinforcement, right? It's gonna happen, right? You're gonna have top reinforcing for the negative moment, and also I'm gonna have bottom reinforcing for the positive moment. So top reinforcing for the negative moment and bottom reinforcement for the positive moment. So again, here I have 9 spans. How much is the span here for the slab? Yeah, say this here 28 feet. Just take this number here, divide by 3. And all the spans is gonna be equal. So this is gonna be slightly off 7 feet. Is it 7 feet? Excuse me, 28, 27 is gonna be 9 feet. It's gonna be slightly off 9 feet. It's gonna be 8 in fraction. Okay. Now, when it comes to dead load on live load, I guess I have a good example on how to do dead load on live load. Now, I'd like to do the moment diagram. It's okay, here we go. You have this document also. So you can do this moment diagram. As I said, you can extend this to 100 spans if you want to. In our case, we have here 9 spans. So my question to you is, what is the maximum negative moment that you have according to this? Can someone figure this out? How much is the maximum moment in this case? Yes? Exactly. Thank you, Eddie. How about the positive moment? What is the maximum positive moment? This is going to be this number here because this number is higher than this number. Now, where would you put the reinforcing for the negative moment? I'm going to say reinforcing for the negative moment. I'm going to put it on the top of the slab. So this is like the center line of the slab. How about for the positive moment? I'm going to say here you need to put it right here at the bottom of the slab. Which means in the same slab, I'm going to have here top reinforcing and bottom reinforcement. The top to resist this negative moment and the bottom to resist this positive moment. This moment diagram, Oscar, if you go please to under project, you're going to see all of these documents. So everything that I'm talking here about, I'm going to open it up and put it there. Is going to be under your project assignment and then project. You can look at it now, or you can just stay with me and then you can look it up later on Canvas. So I said, okay. So now coming up with the dead load on live load based on this given information, I have it. I have dead load, I have live load, right, based on this. And with that, I should be able to figure out the demand. Once I found the demand, I can do the moment and the shear if I want to. And when it comes to concrete slab, I just do the moment because we are not there yet as checking any shear in a beam or a slab. So I'm going to say this should be enough. This is all what I need, moment diagram. Now, the other question is, when I do this, I'm looking here at these beams and slabs, right? Do I need to do it? This is going to be one strip? Isn't it the same as this strip? I'm going to say it is. It's the same. How about this strip? Exactly a copy of it. How about this one? Exactly a copy of it. How about this guy here? How many strips? Or how many spans? I'm going to say you have here 5. Do you think it's going to be different to design that 9 spans? I said no, because just for the 3 spans, it's going to be exactly the same design if I'm going to go here for 5 spans or 9 spans, which means the design of this strip is going to be the same as this, 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 because I don't have just one single strip that I'm going to be designing here for W squared divided by 8. All what I have is going to have positive and negative, and I have a good reference here, right? So I can be using this diagram just to make it simple for myself. Let's hear the first submittal. So instead of a homework, I'm going to be calling it submittal. Please, if you have any questions, don't wait for Saturday. Saturday will have the day, let's say half Sunday, and then you ask me a question. Most likely, you cannot finish on time if you're going to be doing it this way. So what I want you to do is to start on it today, and then you ask me a question by next time. If you have no question, it means that you have gone through it and everything is good, then you can just finish yourself. It says here, develop the load criteria for the roof and typical floor. You know that you are going to have here 4-story building. Second is going to be the same as the third, which means this is going to be just one typical level that you need to come up with your load criteria. And also the roof. So what I need from you is to figure out W ultimate. Let's give you your load criteria. W ultimate. How much is this W ultimate? We're going to say equals 1.4 dead. Also W ultimate equals 1.2 dead plus 1.6 live. We know where this is from, right? Slide set 3, you're going to be going here to the load combinations. And the question is, how much is the dead load? You have a very good example. Look at the example. See how the dead load was determined. It's going to be based on the slab thickness and any additional dead load, just for the dead load. The roof and the typical level is going to have the same dead load. But when it comes to live load for the typical floor, according to the given information here, let me put it back. It says live load, 15 PSF partitions, and then you have the floor live load. For the roof, is going to be 20 PSF. So we're going to say here roof live load, or live load for roof, equals, we're going to say equals 20 PSF. This when it comes to the roof live load. Do I have any partitions above the roof? Do you guys put partitions above the roof or no? None.
Hope not.
None, right? Okay. How about the floor? Because here, this is going to be the live load for the floor. It's going to be equal to how much? 50 plus 15. 65 PSF. This is what you need to design for. Okay. How about now dead load? Dead load for the roof and for the typical floor is going to be the same. Self weight of the structure member. What is the thickness of this? I mean, what thickness are we talking about when it comes to this one? So let me put this back for the submittal. Do we have the slab thickness? Do we have it here? Do you guys see the slab thickness? Do you have the slab thickness here? You see it anywhere? Yes or no?
No.
No.
So someone needs to come up with the slab thickness estimate. What would be a good estimate in your opinion?
12 inches.
12 inches?
Okay, this is for 14 foot, right? What is the span of this? The span of this slab. Is it 14 feet? This is the slab span? Yes, is it? Is it the one? Or this is the story height?
8.
This is a story height. Oh, 8. I say this is going to be slightly off the 9 feet. Now, let me go back to my slide and let me think about it. It says here, I have 14 feet for the span and I use 10 inch. Now, when the span is about 9 feet, would you use 12 inch or 10 inch or maybe something less? How do you feel, guys, about this? Well, ED says it's smaller. Like how much are you talking about?
8.
8 inch. I would go with 8 inch. I'm not going to go here to 12 inch because 12 inch is going to be very thick for this application. So I guess 8 inches should be fine. So I need to put it here. I'm gonna say consider here to be 8 inches. 8-inch thick. Should be fine for the slab. You're good? I want you to start this evening. I mean, once we're done, start to think about how can you do this.
Can you explain again how you came up with the 8 inches thick?
This is an estimate, but I'd like to have here kind of educated guess or estimate, right? So I know that the span of this slab is about 9 feet. Did you agree? Yes or no?
Yeah.
Yes, it's about 9 feet. I have an example here that we just went through. It says there's a 10-inch thick one-way slab simply supported for a span of 14 feet. So when the span was 14 feet, I used 10-inch thick slab. Now the question is, when the slab is only 9 feet span, what thickness would you use? Would you use 12 inches, 10 inches, or 8 inches? How do you feel about this?
8 inches since
It's 8 inches. Yeah, because it's only 9 feet. So I'm gonna say, well, 8 inches should be fine. Good question came here. We need to look at all of these components, right? We need to understand more. I understand the self-weight of the structural member, right? I understand dead load, additional dead load. Do you guys know what is this additional dead load? Like what? Light fixtures, stuff like this, right? About the partitions, what are these partitions? What's the meaning of the partition? Can someone help me with partitions?
Is that a wall?
Yeah, the walls. Which walls? The light frame wall, like made out of metal stud or wood, right? Wood studs. We call this partitions. All right. So what does it mean by life load? What is a life load? What does this account for? The life load. Life load means what?
Like furniture and people.
Furniture.
Yeah. People, furniture, anything that you put there. How about equipment? Is equipment part of the life load?
Yes.
Which equipment?
Yes.
Like air conditioning unit is gonna be life load?
Yes.
No. The life load equipment is gonna be like computers, like big copy machine. You still call it an equipment and you consider it as part of the life load. This dead load, the additional dead load, you can also include, let's say, elevator. Let's say I'm gonna say motor. I'm gonna say AC unit, rooftop unit, right? Anything that you put as permanent equipment, you'd call this to be dead load, not life load. Partition weight is considered to be life load according to the code. In the past, it used to be dead load. And then roughly about 15 years ago, they changed it, the partitions, and so to be dead load, they make it now life load because you can change it. I know that you're not going to be changing this partitions every day, but any partitions, just speaking, there is more uncertainty factor in there, so they decided in the code to make it as life load. But if you asked me this question 15 years ago, I'd have said, of course, it's going to be dead load. This is what the code says. Now let's look here at the rest of this requirement. So you're going to be doing the load criteria for the roof and typical floor. Item number 2, it says design a typical one-way concrete slab at the roof at typical floor, which means you're going to have your 2 designs. Just 1 strip at the roof level and 1 strip at the typical level. Now, I'm not asking you here to do design for this and this and this and this and this. This is going to be only one of them. Just take this one. Start with this one. This should be enough. Sufficient. You're going to have maximum positive is going to happen right here, the first span, and the maximum negative is going to happen right here. Or how do I know this? I'm going to say, let me go back here. Get this going. Maximum positive, it happens right here, the first span, and maximum negative happens at this span. So total, how many sections would I do for one strip? I'm gonna have maximum negative, maximum positive. It's gonna be 2. How many slabs do you think I'm gonna be working on? I'm gonna have 2 slabs. One is gonna be in the typical level, one's gonna be in the roof. How do I know this? Because written right here, look at this. It says here, design one typical, just one typical for negative and positive moment. At the roof, give you number 1 and typical floor. Any questions on slab design and your project?
Yeah, I have a question about the span of the slab.
Yeah.
So you said it goes like a typical span is from one connection to the next connection.
Yeah, from one beam to another beam, one support to another support. This is correct.
So each part, so all those dashed lines are all beams, correct?
Yeah. So how much is this? How much is the span for this slab? We say 28 divided by 3. Exactly. Am I correct? Yeah, because this is equal, right? So this distance is going to be, let me put it here. So it's going to be recorded in our lecture, and you can go back to it. It's going to be 28 feet divided by 3. This is going to be the span, or slab span. All right? Good question. More questions, or you guys are good like this, or how do you feel about it? Now, the question is, I'd like to do a check here just for myself. It's not going to be part of any submittals. I'd like to understand, would you consider this to be one-way slab or two-way slab? What does it mean by one-way and two-way? The load here is going to be going in this direction. It's going to be going like this, and it's going to be going like this, right? Let's say in this bay, it's going to be going in this direction, Nothing's going to be going in that direction. Reasons because code says if L divided by B for one bay, here's one bay. If you take here the length, this length, divided by the width. If it's going to be more than 2, which means the aspect ratio, which means this box here is going to be more like rectangular in shape, and this is going to be like, this is going to be very long compared to this by a factor of 2. They're going to be saying, well, load is going to be going here in the short direction. Now let me think about this. Roughly, how much is this? I'm going to say here 26 feet divided by 9. Is this more than 2? So yeah, absolutely, more than 2. So in this case, it's going to be one-way slab. So just to confirm for myself, but I don't need to solve for that. I've not been asked for this, but this is also for us to understand the meaning of one-way slab versus two-way slab and the performance, the behavior of it. You have a slab, which is like this square box, right? Like a box here, square. And then you have 4 beams on the perimeter. Some load is going to be going this way, right? And some load also is going to be going that way. Same thing in the other direction. Load is going to be going in 4 directions. You're in 2 directions, if you like to call it, right? East, west, and north, south. But this is going to be like a square. Aspect ratio is going to be less than 2. But if you have something like this, what's going to happen? Half the load is going to be traveling this way, and half the load is going to be traveling this way, and that's it. Nothing is going to be going in the long direction. If the aspect ratio, which means length to width, is going to be more than 2, we're going to be calling it, or it's going to be performed as one-way slab, like in our case here. Any questions? Or you guys are good? Project should be simple. Yes, go ahead.
On the project statement on section 1.3 for material properties, it says that it's a 4,000 PSI for two-way slabs. We just use it as a one-way slab, right? Like it's not a problem.
Yeah.
One-way slab. Okay, never mind.
Yeah. And one-way slab. Okay.
So we need one moment diagram for the floor and one for the second and third.
If you like, yes, this would be good. Okay, this is correct. You need to show where you get the moment from. This moment diagram, where did you get it from?
Excuse me, Professor. I couldn't find the moment diagram PDF in the Canvas.
Give me a second. You go to assignment. go to assignment? Yes?
Yes, yes,
And then you go to project. Did you see project?
yes. Project information.
Project information. It's right here. And now I see here that I have 3 files.
Yes.
Professor, so would you like us to turn it in as like just the calculations
Yeah.
with the moment diagram, or you want us to include the actual diagram?
You can use the actual diagram as your background and just type on the top of it if you like in a PDF. Or if you like, you can just do hand calculations. It's gonna be up to you. You
Okay.
decide on.
Thank you.
No problem.
Excuse me, Professor. There are 3 PDFs, but no moment diagram.
Let me check. I'm checking right now. Should have 4 now, right? I just put on the top of each other in a way so that's giving you like readable. You see this moment diagram? Do you see it now?
Yeah.
Yeah, it's available.
It's
on it.
kind
Thank
of
you.
hidden in this one. Okay, good.
Thank you, Professor.
No problem.
So we have to do a design for both the positive moment, the max positive moment, and the max negative moment.
This is correct. Yeah, that's it. Just 2 values.
So like in the example that we did at the beginning of the class, there was like only 1 value, right?
Yeah, because it was only positive one. We consider only simply supported case.
So we're going to do basically what we did in the example, but also have to take into consideration that max positive.
Maximum positive, maximum negative. Right. This is correct. All right.
And after a certain amount of time, it starts to repeat, right?
Yeah, because you can repeat it 4 times, right? Once you have the moment, you have the width, you need to put some reinforcement there and be sure this can be above the minimum, right? So you can do, let's say, number 5 at 16. Don't go for a spacing more than 16 inch, okay? Try to keep it 16 inch max, or maybe 14 inch max, right? And then figure out the minimum reinforcement. This is why you need to have a spreadsheet. Are you done with your spreadsheet or no? Did you do one? You remember we talked about doing a spreadsheet? A spreadsheet now is going to be very helpful. Yeah, because now you can do spreadsheet for the reinforcing. You put, for example, I'm going to put here number 5 at 14 or number 5 at 16. Or you can say number 4 at 16 inch, number 4 at 14 inch, number 4 at 12. And every time you're going to be just putting the reinforcing there, you're going to have P man and the output. And then you compare it with your M sub U and see which program is good for you. I mean, which reinforcing amount is good for you. And then at the end, once you have your choice, you're gonna start to put your calculation together and send it to me. So it's a good thing about the spreadsheet is gonna help you out to decide what reinforcing to use there, and instead of doing it by hand and repeat it like 3-4 times before you're done. And the good thing about it, whatever that you do for the first section, let's say maximum positive in the floor level, and then you do maximum positive in the roof level, maximum negative, maximum negative. Just save you lots of time if you have a spreadsheet. If you don't like spreadsheets and you like to do it by hand, it's fine. Because you're fine. Okay? Questions, or should we open this up? We have like 4 or 5 minutes. So it's gonna be up to you. I can start on this one or just spend the time answer questions from you. Yeah, your analysis is gonna include the third and the second. It's gonna be 1 level. The third and the second will go to the typical level. recording of making a spreadsheet. This is going to be very interesting. Make your own. You understand the topic. You have the equations. So you need to develop the spreadsheet, right, with the equations you know of. And this is also considered to be study time. That's why I asked you to do a spreadsheet for your, for your sake. It's going to save you time and also develop the spreadsheet itself. You need to go through the equations, and also you need to check. You need to put an example. You take, for example, one of the solved examples, like the one we have here, right? After you're done, and then you start to put the numbers that you have in here, and then you be sure that you are matching these numbers. So you confirm your spreadsheet. Was one good example. Now, this section here is going to be about T-beams. When we did the design of the beam, we assumed to be rectangular, and then we put reinforcing only in the tension side. As I said, reality are going to have T-beams, right? There's never a rectangular beam. This is what we have. Look at this aspect ratio in slabs. You see the slab here? The span of the slab here is 15 feet. And the bay, one bay is going to be 32 by 15. It's going to be more than two. It's going to be one-way slab, one-way slab. When you look here, when you take a section through the slab like this AA, you're going to have one beam, second, and the third, and here's the slab. Each one of them is going to be like a T section. And this behind here, this is going to be the girder, right? Supporting girder is going to be this one. And this is going to be the beam. Some cases, girder is going to be deeper than the beam. In other cases, it can be with the same depth. But girder supports the beam, which means the beam itself is going to be spanning from this one girder to another girder. So the question is, yes, go ahead.
Is that true for two-way slabs as well, or does the girder also support the slab in that instant?
In two-way slab, there is no girders. There's no beams.
What would you call the supporting member then?
Columns. You remember this?
Yeah, I see.
This is a two-way slab, most likely. But if you have some beams, most likely this two-way slab, just, two-way slab usually refers to a slab without beams. But in some cases, you have beams, and then you have also two-way slab, and you just call it a beam and a girder. It's going to be the same thing. So for example, if I'm going to be taking one of these, right? And the aspect ratio is going to be, let's say, 1:1. Just imagine that you're going to be taking this grid line A and make the spacing here from A to B is going to be 15 feet, right? It's going to be 15 by 15. So you do the analysis on the beams, the analysis is going to be slightly different. And also for the slab design, it's going to be a little bit different. This is the whole thing.
Okay, thank
you. No problem. Now the design again of this T-beam is going to be very similar to design of rectangular beam. The only difference that I'm going to have here a flange on the top. But all the equations is going to be the same. Just give me the use of it. You recall when I started with rectangular section, I put only 3 number 8, and the beam was okay, Phi factor is 0.9. All of a sudden, I put 10 number 8. What happened? The strain in the steel was lower than the yield strain, and the stress was lower than the yield stress. So what does it mean by that? It means you're going to have the same equations. At the end, you end up with these equations, right? But it's going to be kind of lengthier. You're going to have more work that you need to do about the strain and so forth. I'm going to stop here. I'll let you go. Please go ahead and sign out. Type your name and see you next time.
Professor, your office hours are Tuesday, Thursday?
No, it is Tuesday. It's going to be right after this lecture. So if you like, just hang around and go to the other meeting, right? I'll see you there.
Okay.
If you have any questions.
Thank you.
Thank you. Yes, Tim. Any other questions?
Yeah, I was just saying, like, I don't know why I wasn't able to join earlier, but I was like,
Yes, I know. I let you in. I remember
okay.
that.
Thank you. Have a
You
good
should
one.
be fine. You too. Okay, bye. Jake?
Can you hear me, Professor?
Yes.
Just a quick question. When are you going to be posting the solutions for the assignments?
I don't really post them, but if you have any questions, let me know. Homework 2, you have the solution already. And I guess we discussed this before. I'm not sure if you heard it or not, but you need to ask me exactly what question that you have in there, and I can walk you through it and show you the solution if you want to.
Okay, yeah, let me just pull it up real quick, if you don't mind.
Yeah, so would you please see me in the office hour, because some people is gonna be waiting there for me. Just join the office hour meeting, okay?
Okay.
All right, okay, thank you.